Здравствуйте, коллеги.
Hi, dear colleagues. Shall we begin then? I'm happy to see all of you. Let me introduce myself. My name is Sergey Khrenov, and I'm from PVS-Studio. We have been developing static code analyzer for C, C++, C#, and Java. Today, I want to tell you about how static analyzers can help to fight the errors and become the additional threshold for errors. I will start with a joke. The point of this slide is that we're all seeking to minimize the number of errors in our code, and we're doing for that everything that we can. And all that cannot be done, but yet somehow that does not always work out. The time flies. The software is becoming overly complicated. Code base is increasing endlessly, and there's legacy code that can never be deleted. So that is why we developers, testers, have to apply more and more effort to make quality products. Also, the requirements to code are increasing. That is why we have a certain range of problems that we have to discuss today. I have already told you about the volume of the code base. Also, there is a particularly interesting research. I think it's conducted by American University of Technological Research. So the point of the research is that the density of errors is increasing alongside of the broadening of the code base, but in non-linear way. So if you take a software, 1,000 lines of code, you can find one error in there. But if you take the same piece of software, which is now 10,000 lines of code, then there will be not 10 times more errors there, but 100 times more errors than that. So the growth here is non-linear. That is why if we're taking a piece of software with 1 million lines of code, the situation there might be literally catastrophic. Of course, we do not usually get there. There are different ways of testing software. And you will hardly take bare bones code, because everybody's saying that the code has been evolving for years, there were no problems, what kind of errors you can find in there. But there are errors, and a lot of them. Not always critical errors, but there are some. Accordingly, we have to apply additional methods. If there are errors in the code, it means that something has been done in a wrong way, something has been missing. So the requirements to code are very high. So if, for example, we take some 10 years old piece of Photoshop version, there's 100,000 lines of code. Today, now it's millions lines of code, very different requirements, very different level. That is why unit tests and code review would not be enough for this kind of software. Why am I telling you all of this? Because we can be working in different domains, and you can see here the list of different kinds of methods to improve quality of the code. This is just a small excerpt of what you have been using. Many of you will find another 10 points to add to this slide. Nevertheless, there are things that simply do not work. You cannot write a software right away correctly without a single error. Even if your programmers tell you that they're super perfect, they're not being entirely honest. It is impossible to write code today without a single error. But the question is how quickly you identify those errors and in turn correct those errors. Here's a widely spread methodology, code quality observation, code quality measurement. Let me tell you right away, this methodology is pretty good. We apply it in our team. It does work, but it has certain issues. First of all, it costs, because it requires really applying lots of human resources, which cannot be applied to anything else. So instead of writing a code, developer who has experience and skills, usually it's an experienced expert who is invited to code review, he has to deal and pick on somebody else's code. The person can be tired, exhausted, sleepy, so he will also make some errors. So this technology is not entirely reliable. In addition, if we speak about certain architectural issues, well, it can work, but if we speak about some very deep-rooted errors, they will be hard to find and easy to overlook. So in the contemporary world, we do have to apply instrumental tools. It's impossible to survive without them. Here's a very limited list of them too. I have highlighted the so-called analyzers, static and dynamic. Of course, I have mostly highlighted static analyzers because this is the main theme of my presentation. So all of these methods, they're not mutually exclusive. They complete one another, and the key idea that I want to convey today is that you should be using everything that you can afford. Anything that your company can afford should be applied. Anything that you have enough resources or effort to. Any technology is good. Some are better, some are worse, but the more technologies you use, the better your code in production. I mostly pay my attention to static analysis, but I don't mean to say that any other technologies are better or worse, because static analysis has its own advantages and drawbacks. I'm going to be telling you about them. Why do we need all of this? This presentation is useful to those people who tried static analysis or plan to try it, or just acquainted with the technology. If you have been using it, perhaps you will learn some new tools, because you can apply this kind of analysis in the wrong way and even make things worse. I will talk about that too. And without any instrumental tools, you cannot do without, specifically if you earn money with developing your software. So you have to use different kinds of methods somehow. A few words about static analysis. What the hell is that? So, roughly speaking, static analyzer does not correct your code. It just points you to the errors in the code. So, this is the code check without execution. It only needs to be compiled. It has to be compiled to reveal as many links as possible so that you would cover maximum when you do the test. This is specifically good for large-scale projects because you don't have to execute the software. So, if it's a large-scale project, of course, static analysis is slow, but not as slow as for dynamic analysis where you actually need to execute. Of course, static analysis can reveal certain errors where there are no errors. It will point you to errors, so it's a false failure, but that's the drawback of a technology. Technology is never perfect. So if you tune up everything correctly, you will find many real errors. The advantages is that the errors are discovered in the so-called dead or rarely used code. And you do not know how long it will take for somebody to get to that code and use it. It can be used at any given moment, and you can get absolutely unpredictable consequences. For example, if you compare it with dynamic analyzer, they're not digging through dead code. If dynamic analyzer finds an error, that is a true error. With static analyzers, you have to check. So we are analyzing different kinds of methods here. We're writing articles about that, and in many cases, it's hard to understand whether there is an error discovered by static analyzer without actually looking at it manually. You can only assume. Let's move on. So what is static analysis? It's when the machine is telling you that there is a problem in your code. Of course, developers do not love when somebody is messing around with their code and identifying errors, but managers do love it. And overall, it's for the best. It's for the greater good of the project. Specifically, if we talk about the essence. A few words about the advantages and drawbacks. Static analysis is good because it allows to find errors at the earliest stages. For example, you wrote the code, and if you use IDE, any kind of IDE, contemporary analyzers have plugins which at the level of writing the code you can actually see what's wrong with the code. So you can really save up on the development process without making errors upper in the stack. That's great. Also, the code is covered very thoroughly, including dead code, unused code, even the code that you didn't know you had. So, also static analyzers are good because they contain lots of expertise within. Usually they include the many years experience of the patterns studied by the team. So not a single professional, unless you take some super unique people, is aware of all of the base of the code and errors that could be found by the static analyzer. So there could not be a single code review to find those errors. Of course, there are drawbacks of this methodology. Again, they're not that significant. I already mentioned about false positives when there's actually no error there, the so-called noise. You can fight that noise. Usually you tune up your analyzer, and more often than not you do it in C++ code where macros are complex. There are different kinds of custom-made functions, so analyzers can be tuned up to specific programming patterns of your particular team so that the analyzer does not yell in certain situations. If you're using some specific kind of languages like C# or Java, often people drop off the exception stick, so they catch the exceptions, build this exception rule with a certain kind of line, and lose the entire stack as a result. That's the way they write. It's easier for them. You can tell to the analyzer to miss this kind of things. There could be thousands of pieces of code like that, and you will not see those errors ever again. Yes, you can really overlook something significant, but the probability is very low, but you will cut off the large amount of false positives. So, static analysis integration is not a minute deal. It takes time. The larger is your project, the more history it has, the more time you would need to integrate this kind of analysis. But you will be happy in the end. But that's even not even this is the most important thing. The point of this kind of static analysis is not just you do it one time in 3 months or once a year. That's the radically wrong approach. We are using this analyzer because we have some projects which we have to check, and we need to check them and get the pool of errors. But that does not happen in the real life. In the real practice, you look for errors in the code that was written recently, in the fresh code, practically. I will tell you about this in more detail a little bit later. I have deviated a little bit, and a few things about critical errors. You do not always understand how critical the error is. So developers need time to identify that, but at least it's much more efficient than code review, because code review can only be done by the person who is deeply immersed in the process, but not as much as a developer anyway. So after static analysis, the developer who actually wrote the code can quickly tell you whether it's an actual error or not. So this is the real code of the real project. Look. There's an error in the code. Imagine you're at the code review. You see that something, well, they told you that something works in the wrong way somewhere. So a person, unless he's a cyborg, can never find an error here. Here it is. I will not torture you anymore. No need to read this now. I will give you a zoomed in slide with this thing. But this kind of error is an easy find for a static analyzer. So look at it. This is the conditional operator. After the question mark, there's a condition, and it's executed. There are two branches executed for true or false with a variable. You see, they're absolutely the same. So you see this little piece, you see the way it's formatted. It's one line. So I particularly formatted it like this. Now you can see the error. But here, even if you know where the error is, because it's a formatting in one line, and usually these kind of conditional operators are actually coded this way. By the way, it's a mono project, so you can see that the analyzer tells us that there are two absolutely identical conditions. So a variable will always be getting the same figure, the same result. So probably this error has been there for years. You just got wrong color somewhere on your website, getting the same value for every variable, for this variable. But you need to fight this kind of things. So what is the place of static analysis in the development and testing stack? So the thing is that the earlier you find the error, the closer is static analyzer to code and to the person who's writing the code, the better it is. In a perfect world, you use some kind of IDE where right on the fly the developer can see errors. Usually you need to compile some part of the code for that, and you just write a part of code, you compile it, and then analyzer processes it for a couple of seconds, and then developer gets the stack of warnings with potential errors. So a developer can either correct those errors or keep on working. If you don't do that, the error can go upper in the stack. Imagine the next level is QA, testing. We were able to find errors in unit tests, meaning that unit tests are not the best thing for looking errors within them, because there are initially implied error patterns within unit tests. But any test framework has a certain kind of mainframe or code base that manages the code. So this is where we have been able to find errors, making tests work in the wrong way. So if your errors goes upper in the stack, it goes to the assembly server, and that's where it is recommended to use static analysis, but it will work for the entire team because usually assembly servers are different for everybody. Imagine it's a night build. So you have those build servers, and there will be all of the errors generated within the day. Usually static analyzers have good tools to find the blame. You check the blame, you see where's the root of the error, who made this. The manager gets the notification, and then of course there's a feedback. So developers should actively use static analysis before the code goes to the build, because everybody makes errors and you will make it, but this will be your little secret with the static analyzer. And again, the managers don't want to torture their subordinates. They just want to release quality product as quickly as possible. Again, QA. The research of another research of the institute that I have mentioned. So in terms of money, I see this is the average kind of project. It's understandable that there's different level of critical significance for every project. So at the stage of development, the cost of correcting errors is minimal. A couple of clicks from a developer and there's no error. He corrected it and that's it. At the build stage, it's becoming more expensive because you have to put some effort in. At the QA stage, it's even more costly. We've already applied tests. We've already launched some mechanics. So it's getting more and more expensive to correct errors. So God forbid, if we get this error at the release stage, it can get to the end user with all of the resulting consequences. Of course, this is something that we should not allow, but you should be using all of the methods at your disposal, including static analysis at the writing code stage. There are many tools for that, some of them free, some of them paid, some ADE have built-in tools for that now. But you have to understand that all the static analyzers are different, and it would be fundamentally incorrect to compare them, because there are analyzers that are specifically tuned up to look for some smell in the code with a smell, with a stink. There are analyzers that specifically look for vulnerabilities. Some analyzers look for errors. Or I have Visual Studio here as an example. I wrote a white paper on that. Visual Studio has a built-in static analyzer, but it usually warns you about things like names of the variables, which are not very well, or something like this. So you could find something with it, but not really. So the pool of warnings is pretty big, like code with a smell. So it's really hard to find an error, stinking code you can find. A couple of compilers, because contemporary compilers are today pretty advanced in terms of search for errors. It's clear that compiler is not meant for that initially, but contemporary compilers have some very basic tools for that. Some rudimental tools for that, perhaps. But the compiler, of course, has a different mission, as opposed to a specialized project that is written and improved in order to look for errors within static analysis. So, what kind of errors can be revealed with static analysis? Here are the first things that came into my mind. Lots of patterns, different kinds of errors that you can and cannot imagine. And the idea of this iceberg that I have here is that even when you think that you know everything about your code, you cannot even imagine what kind of errors people may come up with. The variety in this universe is so unbelievably high that even if you think that you're a super professional and expert, you can make ridiculous errors and mistakes. Some incomprehensible things can happen in the code. Typos, inexplicable lack of attention and competencies, and there might be some very unexpected and sad mistakes. They actually happen in very significant projects, and they're there for years in some rarely used code, not critical errors, but nobody knows what happens to this code tomorrow. So you should always remember that there's only tip of an iceberg, and that there are errors that are much, much bigger under the water. So, a couple of examples. I gave you simple examples here. There's an error in this constructor. You see, it's a Roslyn product. A few days ago, I had my article published on Hubber about this. We have checked Roslyn again, and this is the zero-day error. The fresh thing. So we get source kind parameter into the code. We assign the parameter, and you see it's just the wrong name for the variable. The difference between the variables is only the registry. So this is the very wrong pattern to replicate. The person just got carried away. So there's no initialization of this property source kind. It's a pretty often thing to happen, actually. So I recommend it to use underscore for this kind of variable or underline for this kind of variable, but that's for you to choose. Another example, not very significant, Amazon Web Services SDK. There's on failure field there, null, and there's a property of that type. I will tell you right away. This kind of error is in the unused code. But look, in the method to get the value for the property, there's an error of addressing, because we used the wrong pattern, we're applying to its own title, so it's the endless recursion. Yes, I have traced the call for this property, and there is no call for this property, but yet, that's why we have not been able to notice this error. But it's there, you can get it on GitHub and find it there. It lives, it exists. And a third simple example from Unity. Take a second, look at what's wrong here. It's a very disappointing mistake. It happens more often than you could imagine. And here is the condition. That is a problem. Instead of and, there's or. So the wrong operand there. So the person wanted to limit page size with a value from 1 to 1,000, and he was supposed to write or. So, but he wrote, he said he was supposed to write and he wrote or. So it's always true. No matter which figure you put into there, it will always be true. So any number, any value that you put into there, it will either more or less than a given figure. So this condition is useless. I don't know how critical this error is. Maybe it will overload something, but this granny is super scared. A few things about the use of static analysis in security. For the security of your code. Why am I talking about this? Because now there's many activities. People are talking a lot about security. This is a big issue. And a year or so ago, we have found out that our analyzers are able to search for potential vulnerabilities. So it turns out there is a group of analyzers that are static analyzers targeted particularly at looking for potential vulnerabilities in your code. And turns out that those errors are pretty regular errors, but those potential vulnerabilities very well correlate with just traditional errors, like typos, the things that I have shown you just now, can lead in the end to vulnerabilities. I will not give you any big examples here, just will show you a few terms here to use on how this thing works. There are all kinds of errors in the code, and there is a base of errors, CWE, common weakness enumeration errors. This is a certain kind of methodology, a range of patterns that can lead to vulnerabilities. The non-profit organization is making this database. You can look for it online, find this methodology, and you will see this most common errors and patterns. With the examples, by the way. So, after we, with this first methodology, inspected our code for these errors, we can discover real vulnerabilities. What is that? That is an error that is documented in the real-life code. When we have been able to find a certain pattern that potentially could lead to exploitation. So there was a way to pull some invalid data, for example. So this CVE, Common Vulnerabilities and Exposures methodology, includes the real vulnerabilities with the number, documented number, with the project, with the date when it was identified. So it's a pretty amusing pyramid with the common weakness errors which can lead to real vulnerabilities listed and documented. And there are a few thousand things like this discovered in 2017, and the list is ever growing. So static analysis allows you even to find for these kind of things too, not only typos. You can find something serious too. Static analysis has to be tested. You have to try it, but in the right way. Choose your tool. Choose a tool that mostly corresponds to your code, your demands, your opportunities, the methods at your disposal. You have to tune it up. Something that I have already mentioned. You need to look at the specifics of your team. Use the mode. Use the mode that will allow you to use for errors only in the fresh code. You have the fresh code written, you find the errors, but all of those old errors, if you have just integrated the project, you can just forget about them for a while. But you should always apply static analysis on a regular basis. Only regular application of static analyzers will give you positive results, because if you use it occasionally, once every 3 months, this is like with compiler warnings. If you turn them off for 3 months, you shall see so many new things, and here is the same thing. You should use it on a daily basis on your dev's machine. That's when things will work out fine and everyone will be happy. You will not need to use synthetic tests. For example, you download certain analyzer and want to understand whether it's good or not. No, synthetic tests are bad because you will never be able to invent and think up of a complex test that will work well with static analyzer. But in the real world, that static analyzer will not work out. Go to GitHub, download a couple of projects and see what's there, or read our articles on Habr. Again, another useful thing to do. So, it's always bad to use projects with little code, because static analysis shines on large-scale projects. If it's a small project, you will either find nothing, or you'd get too many false positives, at least for your taste. If you get a large-scale project, when you launch static analyzer without any specific tuning up, you shall get quite a few real errors as opposed to false positives. So don't really think that this will be a good idea for a small project. And if you want to integrate, you shall have to do it in a careful and thoughtful way. Probably your first launch will give you lots of warnings. It can frighten you. You might get dozens of thousands of warning, especially if you are using some unusual patterns like Misra. If you heard about that, there's this standard Misra, standard on writing correct code. This standard is used for independent built-in systems. It can give you 1,000 of errors, so there is no point to jump and try to fix all of them. Lots of contemporary analyzers can help you to avoid detecting those kind of errors, putting them into suppress base, the base of suppressed errors. And at the next launches of the test, you will simply skip those errors, looking for errors in the new fresh code. Often they tell us, why? The project has been there for years, we have so much code, and we're saying, you're right. So it's been there for years, so probably the errors that you have there are not that critical. Okay, postpone them, put them on the shelf, but just do not make mistakes in the new code. Look for errors in the new code, and improve your project and the quality of it. So it's about the use of constant application. A few things I mentioned today already. Your build server, so if the error is upper in the stack, you do not have to blame your entire team, and just use anything that you can, incremental mode, anything. This will give you a chance to achieve the best of results. And here are conclusions. Pretty obvious. Static analysis will not safeguard you from everything. It might be too expensive for your team, or you might see some additional complications. Be careful with choosing your tools. Do not waste the last of your money on that, but it's worth a try. Maybe this is exactly what you need. Most obviously, this will be just one more threshold against errors. It will make your life easier and decrease your cost of living. Contemporary companies should be using this one if they can afford it. And I'm ready to answer all of your questions. Okay. So a couple of bags with our merch. I'd probably give them for a couple of curious questions. If there are no questions, I'll just give it to the first two people who would come to me. Okay. First question, do they use static analysis in commercial products? I'll share our examples. We're only working with B2B because static analysis is a complex tool and it costs quite a lot of money to develop. And of course, indie developers rarely can afford this kind of tool. Sadly, but this is the market. That is why, if we speak about commercial projects, they're often used, but they can be also used in non-commercial projects. Another very common question, is there a plan analyzer for Go? We're often traveling around the conferences and practically every third visitor that we have when we have a stand asks about this language. For now, we're not planning to add new languages. We have just released the one for Java, Analyzer for Java, and there are many things to do there still. So for now, sadly, no. But we're thinking, we're considering. What is a small code base? Well, a small code base is 100,000 lines of code. In our view, it's not the big code base. We often write an article based on 2, 3, 5 lines of code. That's interesting. Where there's little code, there's no much field for static analysis. That's just the way static analysis goes. The volume of code matters, just the straightforward number of lines of code. Are there actual examples of errors? You need more examples of errors, or what? All of the errors that I have shown you were real errors. The projects that I've shown you, you can just get it on GitHub. Maybe the authors of that software actually read our articles. Usually we just give feedback to authors and they correct their errors, but everything that you have seen today, it's not synthetic, generic examples. Those are real errors from real projects. Another thing. Developers always resist static analysis. People, especially programmers, do not love to have their errors identified. Developers, programmers are very confident people, I know for myself, and it's always very annoying when somebody is messing around with your code, especially if you don't know about it. But if it is happening, do not resist. Please demand to get static analyzer on your machine so that you would be able to interact with it face to face without any blaming, especially if it's a big company where there are people blamed every day, 10 errors in the code today for this dude. Don't get there. Integrate things in the right way. About the key milestones. Not milestones, but what are the hidden threats? Based on our experience, main pitfalls are related to C++ because it's legacy code and you can find anything in there. If you look at our latest articles on Khabr, my colleague Andrei Khabrov described a situation when in C there was something standard that was redefined. And somebody believed that this is a standard method, but it was redefined and it became non-standard and it led to error. This is something that people face in legacy code on a regular basis. An analyzer doesn't know that. It just identified errors, 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 errors. The person did not know that this method is not standard anymore. So sometimes you have to dig deep. It doesn't change error from being an error, but if you wish, we can be talking about this in more detail, because I think we are almost out of time. Let me try to answer more questions then. About Misra, we're working on that now. Of course, nobody supports it fully. There's no analyzer that supports the entirety of Misra. So in Misra now, we support 30 to 40 diagnostics. We are integrating MISRA currently. User-based metrics. This is a separate issue, separate discussion. Speaking about markings, speaking about indexing, it's different. Thank you for the presentation. As far as I remember, your tool used to be paid. It's still paid. Is there anything open source? Do you give discount for open source? How do you get that discount? I have a GitHub project. Can I get a free version to add your analyzer to my project? Thank you for the question. Recently, we have launched this thing. You can get to our website. There's a separate article there, separate menu point saying, I want this for free. So for GitHub, for a free project, you just put the link to your repository and you will get the automatic enterprise grade key for a year. So there is a way. Well, thank you so much. Great. Dear colleagues, thank you. Can you teach this analyzer to identify very specific errors, for example, for localization? So check the code whether it's vulnerable after it's localized. After localization, so for example, when there's software and you translate it for a different language. So you should not lose functionality because the line is incorrectly compiled. We're not looking this kind of architecture-related issue. We're more into low-level errors, but we have this common practice when for our clients we do diagnostics on demand and based on a certain rule, or sometimes a person can write us an email saying there is something particularly interesting in my project. So we're doing that. We have even the class of diagnostics. It's called on demand. Just the way it is. It's hard to evaluate your situation, but on demand from the client, we're doing these kind of things. This can be done, but the development of a new diagnostics is not something out of the box solution, generic solution. It's not that we just rewrite XML configuration. Every kind of diagnostics includes from 100 to 3,000 to 4,000 lines of code with many exceptions, and we need to test that too. So we have to launch it a few dozen times based on our pool of open projects, where again and again we try to tune up our diagnostics in a more precise way. So it's not simply a checker. No. It's a very, very intellectual method. If you want, there is this booth for communication. I can briefly tell you about the technology so that you will get general understanding. It's pretty much, it's very knowledge-based, knowledge-intensive. Data flow analysis, the procedure analysis. Lots of tech in there. It's not as easy as it seems. Thank you very much. If you have any more questions to ask, we have the question corner. You can get there and ask the questions if you need.